Hello, in this exercise I will show you how to use ultrasonic sensor to measure the distance to an object or obstacle using Arduino. An ultrasonic sensor is a device used to measure the distance to an object or obstacle using sound waves. It operates by emitting high frequency sound waves, ultrasound, and measuring the time it takes for the echo to return after reflecting off an object. Let's see step by step this functionality. At the first, Arduino sends the trigger signal. You can see the code. The sensor automatically emits 8 ultrasonic waves at 40 kHz. Then echo pin goes high. When the sensor sends a pulse, the echo pin becomes high. The sensor detects the returning wave. When the ultrasonic wave reflects from an object and returns, the echo pin goes low. The sensor then calculates the time between sending and receiving the signal. Since the speed of sound in the air is approximately 340 meters per second or 0.034 centimeters per microsecond, the distance to the object can be determined using the formula. Distance equal time multiply speed of sound divided by 2. On this picture you can see the wires diagram. This can be connected using breadboard or without breadboard. You need to connect the 5V pin to VCC pin on the ultrasonic sensor. That wire is red. Next you can connect the trigger and echo pin on the ultrasonic sensor to some digital pin on the Arduino. In our case that will be the pins the pin number 9 for trigger, that will be in the orange color, and second one is connected to digital pin number 10. This color is green one. And the last one will be ground. The ground wire is in a black color. You need to connect the ground pin on the Arduino with ground pin on ultrasonic sensor. Go to Tinkercad and let's create code. I will set 3 variables at first. Trigger pin is set to number 9, echo pin set to number 10. That will be constant data. We will set sound speed in unit. I will set the speed of the sound in centimeter per microsecond. In the air, this will be 0.034. We will create setup method and set pin mode. Trigger pin will be output and echo pin will be input. We will pass, in this case, trigger pin must be output and echo pin must be input. Serial.begin says that reading for serial port started. Baud rate is set to 115, 200. In the loop method, we will use the method measure distance. This method is created later. This method will be return distance from the obstacle or some object, and we will save that in variable float type, variable name distance. Check if distance not less than 0. If yes, we will print this text out of range and no echo received. If the distance greater than 0 or equal 0, we will print that distance to serial port, or in our cases it is printed to serial monitor. We will set 2 decimal places and unit centimeters. On the end of the method we will set some pause before next measurement. I will explain the measure distance method. At the first we will set trigger pin value to low, make some pause to 2 milliseconds, and then using digital write method we will set trigger pin to high. That will be start sending sound wave around. After 10 milliseconds we will set trigger pin to low and stop sending waves. These waves travel through the air, bounce off some obstacle and return back to the echo sensor. The method pulseIn return duration of traveling these waves. PulseIn method give 3 parameters: echo pin, high value of signal, and time for timeout. If it is okay, duration must be greater than 0. We will check for timeout or no echo. In this case we will return -1. Next we need to do is calculate distance using that formula: duration multiply speed of sound and divided by 2, because waves pass twice through the distance. Start simulation and you can see in serial monitor distance to obstacle.